friends, in the next series of the comparator, we are going to see advantages and disadvantages of comparators. Already you have been knowing the basic two comparators from the syllabus. The first is dial indicator, second is Johansson's microcator, out of which for the dial indicator we have performed a practical during practical session. Let us conclude advantages of mechanical comparator. They do not require any external source of energy. Now this is an actual plus point. Without using automotive or without using external force or source of energy, we can do working on that. These are cheapest and portable. As you have handled it during your practical session, you know how portable it is. These are robust in construction and compact design. Therefore, you have handled it very easily. The simple linear scales are easy to read. Now we have seen the least count for the same also, and you have seen the movement of finger, dial finger. These are unaffected by variations due to external source of energy, such as while working, we have kept it open, but the airflow doesn't affect it. Electricity, magnetism haven't affected on the working of dial indicator. Also, any material like plastic or metal we have worked satisfactorily during practical session. Moving to the disadvantages, range is limited as pointer moves over a fixed scale. Now this is a serious issue. You cannot get larger variations noted in the dial indicator. Pointer scale system use can cause parallax error. As I have stated in the lecture, parallax error is a sort of human error. It causes due to the untrue watching in the scale, so that may occur. There are number of moving parts which create problems due to friction, and ultimately accuracy is less since the system uses of gears, plungers, rack and pinion movements. So after prolonged use, there is wear and tear of the parts, so accuracy may be decreased. The instrument may become sensitive due to vibrations and high inertia. Now vibrations may give false reading. There will be readings, but due to continuous vibrations, the plunger is not going to move accurate, that like a steady surface, and the vibrations may create a serious problem. We are going to the next category of comparator, that is mechanical optical comparators. The principle is, let us first understand the principle of mechanical optical comparator. In mechanical optical comparator, small variation in the plunger, that is movement of plunger in the y dash direction, will be magnified first by mechanical system, and the mechanical system will be give the more magnification towards optical system. Construction we can see from the diagram itself. Next. Now this is the construction and ray diagram, or it can be called as perfect ray diagram for the profile projector, as we have conducted the same experiment in the experiment number 1, measurement using profile projector. We can see the ray diagram starting from the top. Light source is the source which gives light to the machine for the better visibility. Condenser is the source of light reductor, where it condenses unwanted rays coming from the light source. Projection lens is the lens used for projecting the rays. Mirror is used for ray diffraction, or we call it as a diffraction of light. The screen gives accurate reading, or the display gives view or visibility. There is optical magnification which is obtained by plunger movement. Now we can see at the bottom our piece is having variations, that is it is having some crest and some troughs which are to be noted by plunger. plunger will give reading in the form of small movement. That movement will be magnified using a mirror and arrangement of pulley that will give us directly a magnified view of errors, or you can call it as a variation. So this is the beauty of this mechanical optical comparator. Next. Now, basic point for using mechanical optical comparator is to discuss advantage and disadvantage points with you. First, we will see advantages. These comparators are almost weightless and have less number of moving parts. Due to that, there is less wear and hence less friction. That is, higher range even at a high magnification is possible as scale moves past the index. The scale can be made to move past datum line and without having any parallax error. As stated, the screen is going to give us a magnified view, so less chances of parallax error. They are used to magnify parts of very small size and of complex configuration such as intricate grooves or radii or steps. Now, the dial indicator and Johansson's microcator were unable to go inside the component and take the reading, but since over here we can get it accurately. That means you can have a statement that the disadvantages of dial indicator and Johnson's microcator are eliminated and converted into advantages one, but the system has some of the disadvantages. Let us see. The accuracy of measurement is limited to 0.001 mm. They have their own built-in illuminated device which tends to hit the instrument, so sometimes it is not useful to connect instruments on a continuous basis. Electrical supply is constantly required, which was not required in the previous segments. Eyepiece type instrument may cause strain on the operator, therefore giving fatigue to the operator. Projection type instruments occupy large space and they are expensive. When the scale is projected on a screen, then it is essential to take the instrument to a dark room in order to take readings easily. That means outer light may affect on the reading, giving some of the errors. Moving to the next most advanced comparator segment, that is sigma comparator. The plunger is attached to a bar which is supported between bending plates and the top and bottom portion. Already you have written these statements during our lecture. Let us see it into the diagram. Yes. Now the diagram is itself self-explanatory type which use the readings. On the top position there is a bending plate. A knife edge component is being attached. The sapphire plate is fixed on a fixed block with the help of cross pin and moving block for the adjustment. Bar is connected to knife edge and very sharp point has been obtained. Also, the bending plate is at the bottom position. Bar is connected to the Y arc. Y arc will give moment to driving arc or driving drum, and driving drum is going to give us pointer that will be notified on the scale. The bottom plunger is connected or it is in contact with the jaw. You can see on the B diagram how the view in 3D. Now how operation works, the jaw is placed at its position. Plunger will move up down, that means in the y dash direction. While moving, it will sense the up crest, down bottom, and it will be on a y dash movement. That y dash movement will be noted by knife edge. The knife edge is connected to the cross pin that is directly going to give input to driving drum. Dependent on the horizontal movement, driving drum will give us the pointer movement, and that pointer movement is noted onto the scale. So this is the working of sigma comparator. Next. Now for formula segment, if I is the distance from each pivot to knife edge. L is length of the Y arm shown. R is the driving drum radius. D is length of the pointer. Then the formula for total magnification can be plotted as total magnification is equal to L divided by I bracket complete into D by R. Up till now, we have covered mechanical comparators in which we have seen dial indicator and Johansson's microcator. In the next segment, we have seen mechanical and optical comparator combination where we have seen sigma comparator thoroughly. In the next lecture, we are going to cover remaining comparators. Thank you.